This team is conducting a first-of-its-kind mission to quantify the number of microplastics and debris in the Chesapeake Bay.
It's blowing 20 knots. Up here this far, up the Potomac River, by DC, it's like 2-foot waves, and I can't help but notice a bunch of floating trash washing by. So, I mean, this is just the situation in an urban harbor, especially during a major windstorm event and rainstorm event. You're going to have lots of stuff washing downstream.
They are looking for these little wisps of color known as microplastics. Microplastics come from larger plastic material that breaks down into smaller bits of plastic over time. They eventually will become so small that they're hardly visible to the human eye. Examples can be plastic bottles, bags, and even threads from synthetic clothing.
So we're seeing something like around 165, 170 plastic particles floating in a dishwasher-sized volume of water throughout the bay.
According to the National Oceanic and Atmospheric Administration, or NOAA, microplastics are found throughout the ocean, from tropical waters to polar ice, fresh water, and the air we breathe.
There is all kinds of different types of man-made pollution that gets into the water, that gets into the bay. So it's not necessarily just small broken down pieces of plastic from consumer products. It also can be broken down pieces of rubber from tires that get in the water. It can be a lot of other different man-made materials. But plastics is the most dominant of the material that we're seeing.
While little is still known about the effects of microplastic and debris, scientists hypothesize that it is affecting plant growth, wildlife, and even humans by being trapped in water. To help track water quality, the University of Maryland Center for Environmental Sciences publishes a report card on the water quality of the Chesapeake Bay and watershed.
What we hope to do is just give everyone an update. How is the bay doing? How is the watershed doing? Also, not just ecological indicators, but social and economic indicators as well.
The university is partnering with an Annapolis-based nonprofit called the Ocean Research Project, co-founded by Nicole, to find out just how much microplastic and debris is in the Chesapeake Bay.
We're going out there and we collect observations to learn more about the changing health of the marine environment.
Ocean Research Project has been conducting studies in some of the world's most remote waters, from the equator to the Arctic. What makes a study like this possible is the organization's use of sailboats, which significantly reduces scientists' expenses.
Historically, it started that way. One would use sailing research vessels around the world and so on to collect observations. We're continuing that legacy, and we need to right now with reducing our environmental footprint the best that we can. We didn't have to use a whole lot of fuel. We could sail as often as we had the wind in our favor, which was quite regularly, and we could sail between the different locations that we are collecting data. You can really reduce your need for fossil fuels to conduct your environmental observations.
To understand the amount of microplastics and debris in the water, the team will be taking samples from the mouth of each of the major rivers leading into the bay.
First stations we'll knock out is Chop Tank.
Yep.
We'll hit up Eastern Bay too.
Okay.
That'll give us a couple hours in between to feel good about life. We wanted to be able to collect water for measuring the micro debris and microplastic in the water as efficiently as possible. So we decided to set up a sampling system over the front of the boat, over the bow, and on that pole was a hose, and that hose would be sucking up the water, pumping that water into the lab that's in the boat where we would be collecting the sample. So, we wanted to have this location of nowhere near any potential of getting pollution from the boat itself, and so that's why that sampling site was at the front of the boat.
grabbing the sediment we just collected, putting it in a mason jar so you can look at it.
The other main aspect of this project is to pull sediment, or in this case mostly mud, from the bay's floor to be analyzed for debris that may be trapped.
Near real time, collecting the water samples as we were sailing around during these surveys, during these cruises, we would be in the lab and we would see absolutely there was microplastics in each of our samples, in each Petri dish. Under the microscope, we could see various colors of different fibers. We could see little pieces of fragments of plastic consumer products, yellow and like very obvious non-organic, non-natural materials. The ocean is not bringing this pollution in. If anything, a lot of it's staying in the northern part of the bay, potentially becoming trapped. There's natural processes at work when you have the fresh water and the salt water coming together in a bay, in an estuary, where you have a kind of convergence zone, a very turbid, like, mixing area. So that might be potentially what's going to have the greater concentration of plastic particle pollution in the bay, maybe stay up in the northern part of the bay.
Nicole and her team are the first to collect this data, and they will be building a method for future scientists to track the change in the amount of microplastics and debris found in the Chesapeake Bay.
This problem is here to stay until we push back on plastics, the use of plastics for everything, especially just kind of one-use type of plastic materials, and then we push back on the use of fossil fuels and such, until we start to use alternatives for lots of plastics. But more in the short term, by regulating filtration of pollutants into the environment, by understanding like what the range is. Right now they have regulations on how much nitrogen or phosphorus from fertilizers or pesticides can run off from counties and areas into the Chesapeake Bay. So we need a threshold for plastic particles, for plastic pollution.
How does it make you feel?
I mean, I don't, it bothers me. I don't like it. This is why we're doing this. You know, I don't like that there's all of this garbage and plastic ending up completely throughout the marine environment. You know, it's having a terrible impact on all of life in the water and out of the water. So we're being part of the exploratory group of researchers out there that are trying to tackle this problem and give the best advice to monitor solutions and understand the severity of the issue.